All right, so we were rudely interrupted to a degree last week, right? Regardless, I uploaded the video of what we have. And I should mention that basically a couple of things. One, a number of students have emailed me saying that, hey, I've turned in my assignments and I'm only just now checking my grades. And I noticed I don't have anything graded for my assignments. And when I asked most of these students somehow did not know that they're supposed to have been demoing these assignments all along. So be sure that you've demoed your assignments.
I demoed my last lab Friday, and I still didn't get a grade.
Yeah, and if you have demoed your assignments and haven't had a grade, send your TA an email. Okay? And if that's not resolved by next week, send me an email and I'll try to fix it myself. Yeah. Yes. Your 416 project. If it's a quiz, it doesn't need to be demoed. If it's under a quiz grade, it doesn't need to be demoed. If it's under the assignment grade, it does need to be demoed. Quiz grades just have to be turned in. So anything that was under here, under quiz that I gave you, like 416, that needs to be turned in. What? Right. Okay. But anything under assignments needs to be demoed in order for you to get a grade. So I fully expect that I will have a mad rush of students as I do most semesters, but we've mentioned that, we kind of will have a cutoff of you've got a month to demo it. So, all right. So keep that in mind. Now, also, in case you weren't here last week and didn't get the announcement, I posted practice questions over here. Okay. So I posted some free response questions, which are excellent practice, I feel, for the computer science writing for the writing portion of your exam. Now there are some stuff like Arraylists that we didn't go over, but that's okay. But the stuff, especially this one, this 2016 one, where we're dealing with array sum and then figuring out how to add arrays and figuring out stuff with 2D arrays, that especially will be pertinent for the final exam. So this one definitely is good practice. Sorry, it's not the 2016, it's the 2015 free response questions. Okay. That being said, you've also got, I also mentioned this one is hard. We didn't go over the switch statement. Some of the stuff over here is tough, but I figure we can go over some of the stuff in here today and see how well that works out. Because a lot of the stuff in this one we didn't end up going over, but let's see. And this one has some good questions with the solutions in regards to, how does the calling of each class and what does each class do. So this is a very good practice on polymorphism. Just the first section of that one. Okay. All right. So let's see what else we had. Be sure to remember your orders of operations. And be sure that we can, that you know how to deal with messy things like this. Right. So let's go ahead and start by going over this problem. So consider the following method. Let's zoom in a bit more so that I can cut off the answer portion. Here we go. So we've got this method over here. Public static void array mystery, an integer array called A. For int I is equal to 1, so anytime you see So remember, most times we go over arrays, we have 0 here and a dot length over here. So this says for each index except for the 0th index and except for the very last index, right? That's what this one's saying. So basically anything that's not an index on the end, we're going to iterate through it, I++. And what we're going to store in there is AI minus 1 minus a of I plus AI plus 1. So that seems like it's rather a lot. But remember, what I minus 1 is, this just means the item to the left. This is the current item, and this is the item to the right of where I am, right? So if you turn it into this thing where basically if you're turning it, oh, minus 1's left, plus 1's right, it's easier to understand. Okay, so let's take a look at this. So indicate in the right-hand column what values would be stored in the array if you pass in the left as the parameter. Right? And this modifies the array is another thing. Remember, this modifies that array. Why? Because it's actually you pass it in and you modify the contents of it. So int A1, 42, 42. So what would the answer for this one be? It's actually not so bad. Right? We're passing in a size 2 array, and this is for anything that's not an end. Right? Well, in a size 2, both of those are the ends. Right? So it's not going to do anything to this. It's not going to iterate at all. The for loop's just not going to run. So our answer is 42, 42. Make sense? It's just not going to happen there. All right. So array mystery A2, 6, 2, and 4. All right. So what we know for this one is, sorry, I didn't mean to reveal the answer. I meant to go up. What we want to do, so for this one, what we know is that we are going to pass in 6, 2, and 4, okay? I believe those are in the inputs. 6, 2, and 4. We're going to pass 6, 2, and 4 into this array. Okay, and then we're going to ask, sorry, into this method. Then we're going to say for anything that's not an end, which is only index 1, right? Index 0, index 2 are at the end, so this is only going to run for I is equal to 1. So we're going to store inside index 1, index 0 minus index 1 plus index 2. Okay? So that was 6, 2, and 4. So 6 minus 2, which is 4, plus 4. So the middle value is going to change to 8. Right? 6, 4, 8, 4. The end values don't change. Right? Over here we get something similar. The end values are not going to change. We already know for this function that 7 and 2 are going to remain steadfastly the same item. Okay? So for this one, then we've got, well, let's copy this over. Now that we know the algorithm, we can copy this over, and then we can start, actually writing stuff down, because this one's a bit bigger than what I can do in my head. All right? So this is index 0, index 1, index 2, index 3. Now you might be wondering why I'm not doing this on the board, because A, because it's going to be hard to capture it on the board, B, because I'm comfortable where I am, and C, because my handwriting is kind of terrible. So I think all of those are perfectly valid answers. Okay, and let me go ahead and just copy the, I'm going to just copy this for loop over here, right, just so that we can remember, so we have it for reference. Or not, right? Because copying from a PDF is always, a bit of a effort and faith, Okay, so so here we go. So we're looking. Remember, we're going to exclude 7 and 2. So we know that 7 and 2 are going to be in the array. Now the big thing that a lot of students missed when we had a question similar to this on the second exam was we got to remember that we're modifying the array as we go through it. Okay, so 7, right? No change there. Now we're at index 1. So index 1 is equal to the left minus itself plus the right. So 7 minus 7 plus 3. So we're going to change this to 3. Okay. Then we're over at index 2. So that's going to be 3 minus 3 plus 8. Which is going to give us 8. Then we're going to get 8 minus 8 plus 2, which is going to give us 2. So that was actually some pretty simple math there. Let's go ahead and see if we got the right answer. 7, 3, 8, 2, and 2. Okay. Now let's look at 4, 2, 3, 1, 2, 5. Easier to copy this one. Right, and in this case, we only go, again, we do this to the middle elements. So 4 minus 2 plus 3, so 2 plus 3 is 5. Okay, 5 minus 3 plus 1, so we get 2 plus 1, which is 3. 3 minus 1 plus 2, so 2 plus 2 is 4. 4 minus 2 plus 5. So 2 plus 5. So that would be 2 plus 5, which is 7. All right, and so on and so forth. I mean, I could do this one. This one's just tricky because it has a negative number, right? So you've got to add or subtract a negative number, but, you know, you can work on that one yourself. But everybody see how basic, the big thing to remember is that basically we since this is modifying the array, we're not copying values over to a new array, but we're working on the original array, okay? The important thing is that to notice that basically the array modifies itself, and so you use each portion of your answer to update the next portion of your answer. Okay, so reference semantics. The program produces, the following program produces 4 lines of output. Write the output below as it would appear on the console. So we import javas.utils.star so we can get the arrays class. Then we have a rectangle, which has a width and a height. Then you have a setter for a width and a height. Sorry, we have a constructor for width and height, not a setter. And then we have a toString method. Then we have reference mystery. Oh, I love these. Except they don't, you know. Because they're needless. They're needfully obtuse so as to confuse you guys, right? So we've got public static void main, and we'll ignore that for now because we don't care about it. Main is what let's look at what mystery does. So mystery takes in an integer. So mystery takes in an int. It takes in a array, and it takes in a rectangle. It increments a value in each of them, prints them out, and then it returns the integer. Okay, that's important. Returns the integer. So let's say we've got n is 20. We've got an array that holds a single item, which is 40. Okay, and then we've got a new array, a rectangle with a rectangle R that has a new as a width and a height. That's 50. And when we plug it into mystery, it's going to increase the height. So the first element was width. Okay, so it has a height of 10. Okay, so let's go ahead and see. So we've got mystery NAR. Okay, so let's go ahead and see what happens. So we pass in 20, and that gets incremented to 21. We pass in this array which has 40 in it, so that gets incremented, and the thing at index 0 gets incremented to 41. And rectangle height, well, that's height, I believe, is, right? Height is the second item, so we get, so that gets incremented to 11, okay? So we're going to print out, in this function, 21, 41, and it's going to print out 50 and 11. Right, so it's going to print out, hey, it's going to print out 21, 41, 50, and 11, you know, and it's going to print out like width is 40 and height, 50, and height is 11 for the rectangle, right? or whatever the toString is. But the main thing is that it's telling me what the width and the height are. Okay, and it's the height that got increased. And then it says return n. So we're going to return 21 as a result of this function. And where does it get returned to? It gets returned to nowhere. Okay, and that's kind of the key, because now when we run this print line statement, we're going to print out the exact same nonsense, except 20 is going to be, sorry, 20, except we're going to put 20 instead of 21. Now why? Well, we incremented the integer over here, right? The int over here. We right? What happens when we pass values? We copy them. So we copy the 20, we copy the memory location of this array, we copy the memory location of this rectangle. And then we return the number, but it doesn't get returned anywhere, so that value doesn't get copied back, essentially. So as a result, we've got 20. Now we increment this element once more. So A22 goes up. Sorry, so now n is equal to 22, and the width is now equal to 51. And now we do NAR again. So that will basically be the same thing, only that we incremented, and we know what's going to be outputted. We just know what the values are. So we put in 20. Now we said 42 plus plus, and then we get a 42 plus plus again, so it's 43. So once over here, and then once when we call the function again. And then we incremented the width. And now this function will increment the height. And then inside of this block also n will get incremented again. So we get that. And then, so that's the output of the first of this third call. And the fourth call is the same as the third call, only n hasn't been incremented. Let's see how badly I did. Only difference is that I use curly braces and I'm missing the commas. So, and on test we do call that negligible. Right. So that's a very good practice problem to understand if you're having trouble with it. And this looks almost this question looks almost identical to the question we did. Sorry, was that a question? Okay. This question looks almost identical to the inheritance problems we went over earlier, right? We've got a Gala, we've got a fruit class, and we've got an apple, which is a type of fruit, a Fuji, which is a type of apple, and a Gala, which is a type of apple, right? And then those override the methods differently, and then we ask you what happened, Yes. Oh. Silly me. So to repeat, this looks surprisingly similar to the type of problem you had earlier, where you've got all these things. So you've got all these methods, right? You've got fruit, you've got the fruit, which has a method 1, method 2. You've got apple, which overrides method 2 and calls method 1. Then you've got Fuji, which is a type of apple, which overrides method 1. And Gala, which overrides method 1 as well, right? So we've got these kinds of so we've got these types of things. Sorry, we've got these. So we've got the similar type of problem, and I think this is an excellent problem for you to work through just to make sure you understand inheritance. All right. Let's see. All right, so this is a pretty, this seems like a pretty good one. So write a static method named computeGrade, which accepts as its parameter a scanner for a file input whose data represents a student's grade for assignments and tests. Your method should compute the student's overall grade percentage from the total points earned on all tests and assignments versus the total points possible for all tests and assignments. The input consists of a series of one or more score records. Each score is represents one of three tokens, where the first is the name of an assignment or a test, the second is the number of points each student earned, and the third is the number of points possible. For example, if the input file contains the following text: homework 1, 40 and 57, test 1, 78 and 100, test 2, 67 and 80, your method would produce the following output. Notice that the percentage is truncated to an integer. Truncated, not rounded. So you've got a homework 40, which is 40 out of 57, 78 out of 100 for test 2, and 67 out of 80. And the 78% comes from adding all the first tokens and dividing by all the second tokens. So, second example. So you suppose you've got an input file that basically looks like this. It's much, and notice the capitalization and spacing. Still works, is kind of the idea. Honor roll should be output if you've got a 90 or higher. So let's look at a possible solution to this. Well, first off, what's different is that they pass in a scanner as the input. Like they mentioned that in the top prompt, that they want a scanner as the input file. Okay. Sorry, so basically you don't have to bother opening a new file. It says I'm passing you a scanner. You can automatically assume the scanner's reading the appropriate file. Okay. And then so now they use input.hasNext, because notice how basically all the lines are kind of messed up, so you can't really rely on hasNext line, right? Because all the lines are completely messed up. You can't assume to be able to read one line at a time. But what you can assume is that basically you've got a string followed by an int followed by an int, and then if there's something else after that, there's going to be a string, then followed by an, and then if there's a string after that, there will be a string followed by an int by an int. So in this case, we're going to use hasNext as opposed to hasNext line. So you'll get the name of whatever you're working on by doing input.next, okay? By basically grabbing it using input.next, then grabbing the score, input.nextInt, then grabbing the percentage that's out of input.nextInt, and then printing out just essentially the name of the assignment, and then the score the division symbol plus the total. Increment your total of points earned by the score and the total number of points that there were available by the total. And then when you're finally done with that, you can figure out the grade by essentially multiplying by 100. Basically multiply it by 100 and divide to turn it into a percentage. And if it's greater than 90, honor roll. It looks harder than it is. Let's see. So let's see. Write a static method named isConsecutive that accepts an array of ints as a parameter and returns true if the integers contain a sequence of increasing consecutive integers and false otherwise. Consecutive integers are ones that come after another. 5, 6, 7, 8, 9. Now this is an example of a professor, by the way, being very clever in basically making a problem you probably already encountered seem new by giving you an alternative definition for it, right? So for this one, this is called, for example, if a variable called list1 stores the following values, 16, 17, 18, 19, a call on isConsecutive list1 should return true. If instead list1 stored the following sequence of values, 16, 17, 18, 19, 20, 19, then it should return false. Array of of less than 2 elements is considered to be consecutive. So if you're clever, if you've, not necessarily if you're clever, but if you've been programming a bit too much, you might notice what this problem is. But I'll go ahead and program it up anyway. So essentially, it says that that the numbers have to come one after another. Now, I suppose the question I'd ask is, I have to ask myself is basically, do they actually have to be one integer distance apart from another? And I'll say that the answer is no. Okay. So we could have, they're considered consecutive if you've got consecutive even numbers, like 2, 4, 6, 8, or consecutive, consecutive numbers. Just anything that's going to be one number coming after another. So that would be public static Boolean is consecutive int array, takes in an array, and it basically makes sure that each item is less than the number that comes after. Let's say that it's less than the number that comes after it. Okay, that's how you know they're consecutive, right? If 1 is less than 2, then 2 is less than 3, then 3 is less than 4, and so on and so forth, all going to be consecutive. So all you have to do is just check the item next to it to make sure that you're consecutive. If 2 items are not in order, they're not going to be consecutive. So for int I is equal to 0, and here we're going to do while I is less than array.length minus 1, because we don't have to bother going up to the last. We don't have to check the last item against what comes after it, because there's nothing that comes after it. I++. Okay. So if array, and here again, when you're trying to say if you've got a Boolean statement, so a big thing that I noticed that a lot of students made a mistake with is that essentially they would go, okay, they just didn't know how to do Boolean checks for these things when you have to do iteration through arrays, and that's brutal. They would go, okay, so if array I is less than array I plus 1, right? So long as the item on the left is less than the item on the right, which is what we want, right? They go, oh, that's what we want, right? That's what we want. That's what we're looking for. So we're going to return true. And that's wrong. This is completely and utterly wrong, because here you're just breaking your and I mentioned this because I saw this a lot when I was grading some of the early finals that I had to grade. So I do have some students who had already had to take the finals. So I saw this, a lot, and that was an issue. Because what happens here? We check the first item. The first and second item are in order. We return true. And so we don't check any of the other items. So long as the first 2 items are in order, we say it's consecutive. And remember, a return stops the function. Instead, what you want to do when you've got a Boolean statement is basically assume something, and then prove it, and then try to show a counterexample of it. So here we're going to assume that if we make it to the end of our loop, okay, then it's all consecutive. But if we don't make it to the end of our loop, right, so if it's out of order, so let me just flip the sign. If it's greater than or equal to, so if the one on the left is greater than or equal to the one on the right, then it's out of order, which proves that it's not consecutive, so we'll go ahead and return false, right? We found one thing that just makes the whole thing not consecutive, right? As soon as we find something that disproves it, we're going to return false. Because if it doesn't hold for one of these things, then it's not going to hold for the entirety of the thing. So look for basically the check that shows if we answer this Boolean statement once, then we can immediately return, which is typically the false condition. We've already solved this problem in class, by the way, because consecutive is not the term we typically use. We typically use sorted. So this is what I was talking about at the beginning. This is a professor just trying to give you throw an old problem at you by pretending it's a new problem, okay? By giving you a name and just avoiding using synonyms. All right, so let's see. So let's go ahead and see what other problems we have for you guys. So this one I mentioned was hard. Let's see. What is the value? I like this one. So let's start. What is the value of string s after the following line? Okay, so we've got s is equal to new string Iraq, then substring 0 to 2 plus string nophobia substring 3. So we've got arachnophobia basically, but we're only going for specific substrings. Okay, so and then we're going to concatenate them together. Okay, so we've got Iraq. So we want substring 0 to 2 of this, of Iraq. So that's just R, right? Because we've got 0, 1, 2, and substring goes up to, but does not include the final letter. So you've got R plus, and then we've got substring 3. So that means from index 3 to the end. So 0, 1, 2, 3. So this should be arhobia as the answer, which is C. When will you use a private constructor? When you get bored with public. No. So if you want to disallow instantiation of that class from outside the class, if you want to protect your class's members from outside modification, that's when you would want to use private, right? But that's not necessarily when you want to use a private constructor, right? If you want to use, that's when if you want to use private on a private setter or a getter. Never it's not allowed. Well, it is allowed to do private constructors. I showed you. Math has a private constructor, right? And that's if you want to disallow instantiation of the class from outside the class. In other words, when we want to prevent people from making a math object, because that wouldn't make sense, right? Let's see. So let's see. We didn't go over runtime exception, so that's fine. We didn't go over switch statements, but that's fine. Right. So what is the most specific result of the following code? This will be interesting. So we've got an integer of some. We have integer sum ints is equal to new integer 100. What the heck's an integer? Right? We have an int, right? This is something you'll hopefully learn about in 2168. Let's see. I believe I have J shell. Awesome, I do. All right, so what the heck is J shell? By the way, I've shown it like only once or twice. What is J shell? It is a REPL, which is now I've completely answered your question with another question. What the heck is a REPL? So REPL stands for read, evaluate, print, loop. Okay, so and that's literally what it does. It reads what I type in. Int I, so int num is equal to 7. It evaluates it. It prints out the result of that, and then it proceeds to loop. And it's now this is if you've taken Python, the Python shell is a REPL, where you just type in commands. And this was a pretty new feature in Java, relatively speaking. That basically you can do this with Java code. So what's special is that an integer is almost exactly like an int, except it's an object. So and what's cool about it is that I can do something called autoboxing, which transforms ints to integers. Essentially, you can use basically the primitive int and the object integer almost interchangeably, right? No problems there. System.out.println I, it's an int or an integer. So it's essentially no difference from an int or an integer. All right, so here we've got the integer array, sum ints. We've got 100 of them. We've got a sum, okay? So for each integer in our array, right, this is the for each loop. So for each of the integers in our sum ints array, take it and add it to the sum, all right? And now we do system.println sum divided by sum ints.length. All right, so what's the most specific result of this code? The code does not compile, null pointer exception. The sum of 100 integers or 0? Well, let's see. Does it indeed compile? Well, we'll see if we do this. I don't think it's a null pointer exception, by the way. Because, oh, or is it? What are we missing? So, we're missing initialization. So the key here is that how integer that integer is an object, like I mentioned, and int is not an object. So when we create an array of 100 integers, right? If we were to create an array of 100 ints, okay, we'd have 100. All those values would be set to what? What's the default value for an int or any primitive? 0. If it's a Boolean, it's by default set to false because 0 and false are used interchangeably. But integer is an object, right? So what's its default value set to? Any object's default value is set to not to 0. If I've got an array of strings, if this was strings, string, some strings, new string, 100 of them, what is the default value that they're all set to? Null. So we've got 100 nulls here. So now for each integer I in this, we're going to add null. Oh, we can't add null, can we? So probably a null pointer exception there. Right? If it was an array of ints, this would be 0. So just an important lesson there about how the difference between, when you'd get a null. You get a null whenever you've got objects in an array. Okay. So action listener, stuff we didn't go over there. This seems to be like a second class, like what we're hoping to turn 1068 into. All right. So, yeah, this is definitely more along the lines of what we hope to turn 1068 into with the scope of the concept. So, public class A. So this looks like something you'd probably get on this looks like one of the questions that Dr. Fiore likes to write. Okay? So you've got public static int do stuff where you've taken a double x and a double y. Okay? And then we return x divided by y, but then we cast it into an integer. So before we even examine what the code does, let's just note that if we do x divided by y, all right, that's going to do double division because it's in parentheses first. And then it's going to return an integer of that double division. In other words, it's going to do x divided by y like you would on a calculator. And then it's going to throw away all the decimal points. Right? That's what the integer casting does. So let's look at main. And this is actually technically a B. This does not compile because public static actually would compile, but it's not really going to run anything because public static void main is missing string args. So and this is why on my exams I put there are no trick questions except for questions that tell you to, there are no intentional mistakes except for questions that tell you to correct the mistakes because I hate these kind of things, right? Where it's missing the string args. So let's assume it does have the string args and see what it does. Okay. So float x. Because I would ask the professor, did you mean for this to be missing? Right? Because technically it does compile, it just doesn't run. Right? Float x is 6.0. So remember, a float is a smaller double. Essentially, it's a 32-bit floating point as opposed to a 64. Then you've got int y is equal to 11. Do stuff yx. So we're going to pass 11 into here, right? So we switch, right? It's yx and xy over here. So we've passed 11 over here, and that gets converted to 11.0. We get 6 over here, and that gets up converted from a float to a double, so it's still 6.0. And then we do 11 divided by, and then we do 11 divided by 11.0 divided by 6.0, which is none of the answers over there, right? None of those answers are 11.0 divided by 6.0. So it does kind of tell you that, actually, 11.0, yeah, except that you would cast in an integer. So 11.0 divided by 6.0 would be some number that's less than 2 but greater than 1. So when you cast it to an integer, this would return 1 and set x equal to 1. X was the 6.0, so we replace the 6.0, so it'd be 1 and 11 if this thing compiled, which it does, but main won't run because it's missing the string.args. So this is why. So that's why I kind of hate those questions. And so let's see. All right. So an array object, array1 is created as following: float array1, and array is a new. And remember, floats are just like some doubles, okay? So it's a new floating point number, and it means, so we've got basically a matrix with 20 columns, right? And sorry, 20 rows and 10 columns. Suppose array1 is passed as an argument to a method in which the corresponding parameter is SumArray. What should SumArray look like as a parameter in the method? So in other words, how do we declare it in the method? Float bracket 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 SumArray, float SumArray single brackets, float array SumArray brackets 20. And if you've done enough programming, you should immediately know that basically this looks correct. Even though this is the most correct looking, because even though it has a space, right? It has a space there. Can you put a space in there? You can. I don't like it at all, right? Over here I could write float some array, right? I put that in there. I can put the brackets over there. I can also put them, strangely enough, over here. Or can I? What am I missing? Where's my... Oh, right. Now it doesn't like me because I'm messing that up. So I can put them over here. I can put them over here. I can put spaces in between them. Because why? Java doesn't care about your white space. Right? Java doesn't care about the white space. And because some programming languages did do this version as the default, and Java wanted to be friendly to both those programming languages. Okay? But the important thing is that you need two sets of brackets. Okay? The other answers were incorrect for a number of reasons. Okay? These are very glaring, what we would call Newb errors, or people who did not really program too much with passing an array, because you don't, when you pass an array, you don't pass in the numbers, right? Like this. This is just mixing and matching. And this one just would be a single array, and we'd want a double array. Okay. And then we get into a lot of other, extension stuff. Okay. So so that one's like, I have a lot of complex questions, and I'm going to use that as an example of what we want from 1068 later, right? Because I'm sure a lot of you noticed that the curriculum for 1068 changes in the fall, right? I don't necessarily, or rather the requirements for 1068 in the fall change. Right? They require you to take 1051 or 1057 before you do 1068. And I'm not sure if it affects you guys because you guys, you're currently enrolled because, you're currently enrolled under the assumption that you don't need to do that. So I think it only affects incoming freshmen. But as a result, we're going to assume that basically students have taken 1051 and 1068 in spring 2019, just as an FYI. And the reason we do this is just simply so we can get a lot more practice and finesse in 1068 done. Because rather than because if I assume you're coming in already knowing a programming language, I can do basically most of the course except for the last couple weeks in about 4 weeks. So we're hoping to not necessarily speed it up, but basically create a second course where we can go into more concepts where that we don't necessarily go over, like generics, which is a pretty cool concept here. So I'm going to talk to you about today about just something that you might find useful. You can use it on the test. If you know how to use it, you can use it. It's fine, right? That's the big thing about Java. If you know how to use it, you can use it. Right? There's nothing stopping you from using regular expressions. So let me just preface this. So I'm going to tell you about this. This is what you should do over your summer vacation. The only other thing that I would suggest is learning a different language. Like, not necessarily, and I'm not talking programming language. I'm talking like an actual bona fide different language that you've always wanted to, because you've got plenty of time to do that in the summer if you're not working. If you're working, then I guess try to make that as interesting as possible. The other thing is learning regular expressions, because regular expressions are amazing. Basically, this will look for it. This allows you to kind of just search for any kind of thing. You can search for, like, basically here, I'll show you. This is a regular expression, 0 through 9. 3 of those, I'd like 3 0 through 9s, in a row, followed by a dash, followed by exactly 2 0 through 9s, followed by exactly 4 0 through 9s. This matches a social security number in a block of text, or any number that follows the format of a U.S. social security number, which is 3 numbers followed by a dash, followed by 2 numbers, followed by a dash, followed by 4 numbers and a dash. I could potentially shrink this down to slash, to that for a number. But they're really powerful tools that are worthwhile to learn. Okay? Because, you can look for stuff like social security numbers and remove them from your company's website so you don't get sued. Good idea, that. There was actually an interesting case when basically this was much well before the 2016 elections, right? Where basically, if you remember, when Jeb Bush released a whole bunch of emails, right, and they failed to redact them, so there was a lot of personal information up to and including people's social security numbers, which they had emailed to Bush asking him to resolve problems, right? And they emailed him their social security numbers just so that the governor would know who they were. Right, and his IT team. Not him, it was his IT team, right? Because even though the guy at top always takes the blame, it's the IT people who are kind of responsible for this. You should probably redact, if you're working for somebody, you should probably redact the social security numbers in any communications. Good idea, that. It's also a reason like, but anyway, so the other thing that I'd like to teach you is that's useful on your exam is Arraylists. Okay? So what is an Arraylist? And I'm going to teach this to you because some professors don't necessarily even bother going over this in 2168, and they just kind of assume that you're going to pick it up. Which, full disclosure, that's how I learned about Arraylists. They're very easy to use. They're amazingly easy to use. Okay? Arraylists are super simple. And it's worthwhile, and they're even in your textbook, so it's worthwhile, like, putting on your cheat sheet. So, Arraylist. Sorry, no. Delete that. Delete that. Code. New class. Arraylist. Example. And for those of you who already know Arraylist, these are probably this is probably going to be very boring. Public static void main. But what these are is that they're essentially arrays that will grow and shrink as you need them, right? One of the main problems you have with arrays is, like, you don't know how big they're supposed to be, right? For your given problem. So an array list is something that grows and shrinks as you need it. So you create an array list by just saying array list list is equal to a new array list. All right? And this creates basically an array list that can hold anything. the array list can hold, you can add, like, the number 7 to it. We can add a string to it. We can add a new object to it. List.add new, let's just go with object, the generic object class that doesn't do anything. And, it's even easier to print out than arrays because all we have to do is s out and print out the list. And it essentially is, and there's a lot of stuff going on in the background, but essentially it's an array, right, that just grows as you need it. Here's 7, here's chicken. Say we wanted we want to be a bit vegetarian instead, we can go list.set the value at index 1 to tofu instead. Okay, run that, and it switches it out. So you've got essentially 4 methods to that you should know about. Sorry, you've got 5 methods you need to know for array lists. The first is add, to add things, and as you might presume, there's also a remove, which works one of 2 ways. You can list.remove. You can either remove a specific object, or you can remove a thing at an index. So I can remove the object at index 2, and it will automatically remove it and shift everything down accordingly. Let's see. Let me up this. Let's see. Enter presentation. There we go. That's much better. Okay. So it updates the. So if I remove index 1, it will remove everything. It's going to remove everything accordingly. So it automatically shifted down. Automatically shifts down stuff. Here we go. Automatically shifts down stuff. So it removed the chicken. Set chicken to tofu and then removed the tofu, and we print it out. So that's cool. It automatically handles the whole removing things from an array and shifting stuff down. So that's then set things to change values, and then you can use get things to get values. To iterate through an array list, it's fairly straightforward. System.out. So for int I is equal to 0, I is less than list.size. So you use size for lists like this. We can print out list.get I. Now the reason I bring this up is that not only are they useful for exams like that, but just being able to iterate through stuff like that and being able to just slap things together into a collection really quickly like that. What's really powerful about array lists is the use of something called generics, which is essentially that there's a bit of an issue that happens, right? This is essentially on the back end, you've got an array of objects, so we can store anything in there. But say I want to get a variable out, right? Say I change this to storing just integers, okay? 5, 12, right? And I'll leave the tofu there, for example, just to highlight the point, okay? Int I is equal to list.get I. Get the I index out. And I'm not going to call it I got to call it thing. Okay, int thing. Now it gives me an error here because it's saying, hey, we're getting list.get returns an object. You're trying to store an object in an int. Obviously that won't work. And you're going, well, hold on a second. I'm just adding integers to this thing, right? So I should just be able to print out an integer to this thing. But this method over here, and Java's and the compilers are kind of just saying, well, yeah, you might be adding stuff, but you also might set your integer to a string at some point and mess up the whole thing, right? We don't know what happens between here and here. You might change your mind, right? And of course, you can cast it. You could tell Java, hey, that's an integer. But that's frustrating to have to cast everything. And if you forget, and if you try to cast and you accidentally do this, which is what happens in Python plenty of the time. Not the casting, but basically forgetting what you're holding, because everything, there's no typing in Python, or no type checking like that. It says, hey, you can't turn a string into an int. That won't work. So what's really cool about this feature called generics is that you can do this. List of integer. You can't, and you can only do this for object types. This is like one of the reasons that the integer class exists. And you can say, this is an array list, and the only thing it's going to hold are integers. Okay? Does that make sense? This is an array list, and then when you see brackets like this, it says it's an array list of integers. Make sense? It's an array list of integers. Only integers can be added to it. It's enforced by the compiler, right? If I try to go list.add dog, now everybody likes dogs, but apparently the compiler does not, because it's a list of integers. So only integers can go into this. But you might say, now wait, I thought int and integers are different, and the answer is yes, but Java treats ints and integers just the same because that's really convenient. Okay. But everybody understand how this is a list that only holds ints right now? And so now I can store that. So now I can get the value out and I can store it. And then I can print it. Boom. Okay, view. Right. Okay. Awesome. So now let's go ahead. And so if we look at that, so that's something that can be used over here. So when you look at this computer science exam, by the way, this practice computer science exam where it says it has that the public class digits has a array list of integers. Now you know a digit list. That's the list of digits in the numbers, right? And it's just simply saying that it's a list of integers as opposed to an array. And the use of this is, why would you want to use an array list? Well, you want to use it when you would want to use an array, but you want to be able to grow it dynamically, right? Another a term for this is kind of like a dynamic array. It grows and shrinks as you need it. Well, maybe it shrinks. If Java's clever, it will shrink. But most of the times, you just assume that it's going to grow as you need it. Now, it is noon. I'm aware there's 20 minutes left, but honestly, there's not too much to go over at this point. So, for this remaining 20 minutes, if you need to speak to me, I'm going to be right here. If you need a demo stuff to me, I'm going to be right here. Okay? That work for everybody? Okay. So, if you need, if you've got like weird stuff like you pointed out, like having to deal with like final exams, I want to talk to you first. Okay? So finals first, then demos. Okay? And good luck on the final exam.
When's the latest that I should talk to you about rescheduling the exam?
The sooner the better.
I kind of want to talk with every other professor too, so.
The sooner the better.